Hello, guys. Welcome to Cheenta School of Statistics and Data Science. To book a trial class for your preparation courses of IIT MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So let's see this problem. If you observe this problem, you will see that it's given a series format, but the series is in different format. I mean, the lower bound also goes to infinity, and the upper bound also goes to infinity. Okay, so how to deal with this kind of problem? So the basic way to deal with it is very simple. That you um, so you try out various methods. Okay, I tried out various methods myself, and but the basic idea is that you should try out using inequality first. Okay, whether you can bound it. It's called, you can use something called Sandridge theorem. So if you use Sandridge theorem, there can be many methods, but if you use Sandridge theorem, you can get this. I have done this using Sandridge theorem. There can be other methods too. So let's explore this. So observe that 5 to the power, this one, the below format, this initial one is less than, if you observe, m is between n square and 2n square. Okay, so it's this term is less than equal to, if you replace m by n square, and greater than equal to 2n square. Okay, because this is larger than this, so it's 1 by inverse of it will be smaller than this, and vice versa. So similarly, you do the same way out here, and you just take the summation now. If you take the summation now, guys, what will happen? That um, the right side, this are all constants. Okay, doesn't depend on m. So what you can do is that if you take the summation, this will be the actual series, and this left hand side and right hand side will be constant. It's functions of n, and you can observe that it's n square. Okay, it's n square by in one, it's like there are n square terms out there, so the constant is added n square times. So it's n square by the below wala uh, variable expression, and n square times below this variance on right hand side and left hand side respectively. So now observe that, so we have to find it limits. Okay, you have to find limit n tends to infinity, what this happens. So we take the limit on both sides, and observe that it's like comparing the ratio of two polynomials in that sense. So if you observe, if you divide by n square both sides, you will get that it's 1 by, this will turn out to be root 5 plus 1 by n plus some constant by n square. This will turn out, and when n tends to infinity, this goes to 0. So therefore, both of them will go to 1 by root 5. Perfect. And now, this is the basic idea. So now what you will do is the following. You will now go ahead and put that alpha here. Actually, this s is nothing but alpha. And so use what property? We use the property that larger powers. Okay, I hope you understood that. So this is the basic solution idea. It's use Sandridge's theorem, because both the RHS and RA are like, when the right hand limit and left hand limit are same, so there it must goes to 1 by root 5. And if it goes to 1 by root 5, you see that it goes to 10. The value is 10. Okay, I hope you understood this idea, and it uses something very important. And yep, that's it. So if you just revise slowly, you will see that the first one uses Taylor series, the second one uses the Munich convergence theorem, the basic and depth knowledge of sequence. This one used the idea of Sandridge theorem. Okay, so these are really important problem solving techniques that can really help you in your problem solving and enhance your process of problem solving, because after all, after learning the theory, your problem solving is the only thing that keeps an intellectual mind alive and entertained. So okay, perfect. So let's move ahead to the last problem, I guess. Yes. So it's a really easy problem, and it's a problem number 59. So let alpha be like, it's given alpha is defined like this. And observe, if you first thing when you're doing the limit, guys, observe always the first idea is always the format. What format it is, guys? Okay, is it infinity by infinity? Is it 1 to the power infinity? Is it 0 to the power infinity? What type of format? Because depending on the various formats, we solve in different ways. So let's see the format first. What is the type of this limit? So the type of the limit is the following, that okay, it's a bit it's too much cluttered over here, but focus as my as I scroll through the solution. So if you observe that the limit is this format, so first check that where the What is the type? This is checking the type. Okay, if you check the type, you observe that 1 by n square goes to 0, so 3 by n square also goes to 0. Okay, and if 3 by n square goes to 0, then sine 3 by n square by 3 by n square will go to 1, because sine x by x goes to 1 as x tends to 0. Okay, it's a subsequence of that function. So therefore that really helps us in understanding that n times sine 3 by n square will behave like 3 by n, okay, which will go to 0. Okay, that's the basic idea. So this term will go to 0, and you can easily understand this term is going to infinity. Very good, perfect. Now given this knowledge, when you have, therefore it's of the form what? It's of the form 1 to the power infinity format, guys. Okay, that is the format. Now observe it very carefully, that what you can, we can use, you cannot use L'Hopital rule directly in sequence. Okay, because L'Hopital rule has a different aspect to it. Also there's a result. Okay, you prove using L'Hopital rule that so this is a basic idea, this is a core idea, that instead of taking the sequence, you take f of that sequence. Okay, f of n, and you know that f of x is going to that limit. If you can prove f of x going to that limit, then a subsequence of this, because if a function goes to a certain limit, all the sequences that can be created out of that function also go to the same limit if x goes to infinity. Okay, so similarly, if you observe over here that we will try to do it in terms of the function, because we have the results in terms of the function only. So let's observe this, that if you take the result, this is a very important result that can really help you out, that limit fx is this, that its limit x tends to infinity 1 plus gx whole to the power hx, where gx is going towards 0 and hx is going towards infinity. Okay, understand this very carefully. I'm just explaining to you once again. So 1 plus gx whole to the power hx, okay, this goes towards 0, this goes towards infinity. By the exponential, the exponential property, the limit of the exponential 1 plus gx, I'm giving you the proof idea, whole to the power 1 by gx, this will go to the e, okay, since gx is going towards 0. And therefore, to adjust with it, observe this is nothing but 1 plus 1 by 1 plus gx whole to the power 1 by gx, uska whole to the power gx times hx. Now this gx is cancelling this out. So therefore, observe that this turns out to be limit e to the power limit x tends to infinity hx into gx. Okay, this only can happen if you have these two conditions over here. And if you put this value over here, hx and gx value correspondingly, you have 2x squared sine 3 by x squared. And use the same idea over here that I've used here, so that sine 3 by x squared by 3 by x squared will go to 1. So the corresponding adjusting factor is 6. So therefore, this limit will be 6. That means this will be e to the power 6. So you have to find log of this limit, that is, it will turn out to be 6. So this is the basic idea, guys. I hope you enjoyed the problem solving out here.
We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists.